How would you deliver a nuke to the Mariana Trench? What would underwater explosions be like? What kind of destruction would it cause? First, let's move our nuclear weapons from the sea all the way to the sky. Let's nuke hurricanes every year. About half a dozen hurricanes reach the United States, with effects ranging from heavy winds and some flooding to the decimation of communities, destroying homes and taking lives. Instead of bracing for impact with our sandbags and survival kits, what if hurricanes never hit land at all? What if we could stop these hurricanes by nuking them? How would we do it? Could this cause a nuclear apocalypse? Or would a bomb even stop a hurricane? First, what exactly are hurricanes? Well, they're massive storms that form over warm ocean water near the equator. Hurricanes are tropical storms. The water they form over needs to be above 26 degrees for them to work. This warm water creates humid air, which then gets thrust upwards by tropical winds to create storm clouds. Lighter winds outside the clouds steer them and help them grow. This cycle keeps happening until the storm has winds of at least 119 kilometers per hour. At that point, it's called a hurricane. They're usually about 160 kilometers in diameter and can be nearly as large as the state of Texas. These things can last for days. You definitely don't want this coming to your home. So let's nuke, believe it or not. The idea of nuking hurricanes isn't new. It's been proposed for decades, dating back to the 1950s. The idea works like this. A submarine would travel underwater to below the eye of the storm. Once there, the sub would launch the nuclear bomb, creating an explosion intended to blast out all the hot air and bring in cold air, which is denser. The cold air would slow down the wind and stop the hurricane. Now we have our nuke and are ready to launch it. Launched and nothing happened, the hurricane is still there. The reason nothing would happen is because of the amount of energy hurricanes produce. According to the National Oceanic and Atmospheric Administration, the heat released from a hurricane is equal to a 10-megaton nuclear bomb, exploding every 20 minutes. In 1990, all of humanity used 20% less energy than a single hurricane produces, so the average bombs of today would hardly make a dent on a hurricane. Not only that, the hurricane would carry all that radiation, plutonium, and other civilization, destroying materials from the air down to the land. There are further possibilities. If we nuke a hurricane in a different way, then we can have different results. But let's first know what will happen if we nuke underwater, as in at the place of Mariana Trench. Let's see. Welcome to the deepest, darkest depths of the ocean. The Mariana Trench is located in the Western Pacific Ocean, just 360 kilometers away from the island of Guam. You'll be traveling down 11 kilometers to Challenger Deep, the deepest point of the trench. Here you could stack about 30 Empire State Buildings on top of each other before hitting the surface. You'd be among the brave few to venture into these high-pressure, pitch-black, and near-freezing waters, joining the company of scientists, a naval officer, and even filmmaker James Cameron. But you'll be carrying the most precious cargo of all, the biggest nuclear bomb ever made. Okay, before you worry about what would happen if you exploded a bomb at the bottom of the trench, you'd want to figure out how to get it there safely. Right? What if a bomb accidentally exploded near the surface? It could be dangerous for many people. You could think of it as a massive nuclear tsunami, waves hundreds of meters high spreading out in all directions. This could create a hazardous situation for the islands neighboring the Mariana Trench, like Guam, Japan, or the Philippines. Luckily, these waves would behave differently than your regular tsunami waves. They would break earlier. That means they'd be smaller and less catastrophic when they reached land. But still better to avoid this crisis and get that bomb safely down into the trench. To do this, you'd have to protect it from extremely high pressures. At the bottom of the trench, the pressure is so high, it would be like having 100 adult elephants on your head. You'd want to use a special pressure vessel to transport the bomb, just like Operation Wigwam. In 1955, the United States detonated a bomb at a depth of 600 meters. It was twice as powerful as the bomb dropped on Hiroshima. The explosion generated a massive bubble across the water, and deadly radioactive contamination spread across 13 square kilometers. But your bomb would be the largest nuke ever created. This nuclear weapon was over 3,000 times more powerful than Little Boy. The bomb dropped on Nagasaki, and you'd have to take it much, much deeper than the Wigwam test. At the moment of detonation, a bubble of hot steam would expand rapidly. In just a few seconds, it would cover an area of about 1 kilometer. On the surface, you'd see a massive bulge in the water, but it wouldn't reach great heights. That's because you would detonate the bomb so deep that the water pressure above would cause the bubble to collapse. But within a few seconds, that bubble would shrink, then start to expand outward again. This expansion and contraction would continue for 3 or 4 cycles. This would leave the water turbulent hot and mixed with radioactive debris. At least no neighboring coastal cities would have to worry about being wiped out by a tsunami, but you certainly wouldn't see the effects ending there. The increased temperatures from the explosion could create intense hurricanes, and the turbulent waters and radioactive material would have adverse effects on marine life. There would be mass casualties from the explosion, and deep-sea fish could be blinded by the bright flash of light. Over time, you could see unexpected or surprising effects on the ecosystem near the detonation site. There are corals as big as cars. After the 23 detonations at the U.S. nuclear testing site on Bikini Atoll, not to mention an abundance of aquatic animal life. But you could see mutations of marine life after a while. Friends, what are your thoughts about this? Comment down below. Like and share this video and subscribe to our channel for more interesting educational videos. See you in the next video. Until then, thank you for watching.